co-founder and CEO.
Okay, hi. So, unpredicted failures in the energy sector jeopardize energy production, pose massive risk to maintenance cost, and waste time, money, parts, manpower. A typical power plant can lose up to $1.5 million a day due to unexpected malfunctions, and I bet some of you in the audience had faced these dilemmas in their past. So, at MikaGu, we solve this problem. We have a solution that is combined out of hardware and software. The hardware, a network of microphones spread on critical machines like turbines, pumps, generators. These microphones intercept the internal sound that machine makes. We then move this sound to our on-prem AI computer, and we investigate the sound. We examine the sound and give the customer actionable alerts. What are actionable alerts? Is there a problem in your machine? Where and why? And the Holy Grail, when the machine will die. We do it earlier and more accurate due to acoustics and the edge computer. The outcome, 50% reduction in unplanned malfunction and 40% drop in maintenance cost. The market is pretty big, $90 billion market. Predictive maintenance, our signal is $8 billion, growing 27% a year. I am amazed from this number. It means that most solutions are being invented now as we speak, and we have to catch this train. We are different because we are very, very focused only on energy sectors and its machines, only on acoustics, not vibration or video or other legacy trends, and because we built a product that becomes more and more accurate as time goes for the customer due to AI. So we are a bootstrap company with some grants from the IIA that we really appreciate. We did a lot of POCs with Israeli players, and today we are having commercial pilots with our partners and other companies that are not mentioned here. This is our status. My name is Tal, I'm a PhD. I'm focused on AI and acoustics. I was a squadron deputy commander in many squadrons. My co-founder, Omer, the CTO, is a Mamram alumni and had built these kinds of software all of his life in the Air Force. So, if you want to partner up, we are open to work. Let's do a shared pilot. If you want to invest, so stay on your toes because seed round is coming. Thank you very much.
Hi. Ooh, that was loud. Can you share a little bit your go-to-market, how you're going to penetrate all different factories with different machinery? And again, the second question is, how long does it take, in the real life to do the configuration, to set up the baseline, all those classic questions of AI in industrial setting that always look good on paper, but always challenging in reality?
Okay, so we'll start with the second question because we are working with people that had enough with technology and they want that things will work and they don't get any explanations about hallucination from AI. So what we are doing, we just prove it to them. We have pilots with low CapEx, just spread the machines that we have, and for 6 months, 3 months, depends, we just give them measurable KPIs. If it works, they trust us, we can expand. Okay, the first question, go to market. So we identify our ICP as people that are the O&M, which means they need to pay money when things are going bad, and they are also the entrepreneurs. They're losing money if energy is not produced. So if we can find these kinds of people, and there are some, these are the perfect people, they benefit from the technology. We can sell also to people that only the entrepreneurs or the OEM, but we prefer those people. Hope that I answered.
What do you sell?
What do I sell? Insurance.
Insurance?
Insurance.
Explain.
I'm selling you the feeling that you won't have a problem, and if you will have a problem, you will catch it on time and fix it on time, and due to that, You will also maybe can spend a little bit less on maintenance, but I'm selling you a feeling. I'm selling you a insurance. Exactly.
Hi. Question over here. Predictive maintenance, definitely a hot subject, but the result is there's a lot of competition. So a word about the differentiation, the moat from other startups dealing in the field. And a sub-question is, what would you say to the claim that by the time that there is an acoustic resonance or signal, damage is already being done and then should be detected earlier?
Good. Thank you for that question. So when a machine breaks, it's warming up, like your car. Everything starts to burn. Before that, it vibrates a little bit. And before that, it makes tiny anomalies or harmonies in the air. We capture those harmonies. So exactly, we do it earlier than others. So this is one of the differentiators. Also, we give time better than other signals. And because we're using edge computer, we can do it over and over and over again, not sending anything to the cloud, so we are much more accurate. But my biggest competition is not doing nothing. Those what my customers do today, except let's say the main turbine or whatever, most of their equipment is non-motorized. So the biggest enemy is not doing nothing, and we overcome it. So